chemical reactions. When we hear the term chemical reactions, we always associate it with the changes in matter, particularly the chemical change that matter undergoes. Chemical reactions will pave the way for the formation of brand new substances because you would expect that when you have a chemical change, whatever you had initially will be completely new set of substances which will have brand new properties as well. Now I have seen some great videos about chemical change in YouTube, and I hope that you will have time to look at and watch the 10 most amazing chemical reactions so that you would see some amazing chemical changes that matter undergoes with great evidences of chemical change. Third, you have to know that chemical reaction will always alter the properties of your mixed chemicals. And since it's the production of one or more substances, you would expect that old chemical bonds will be broken and then you would form brand new chemical bonds. And some chemical reactions will require some significant elements like heat, pressure, radiation, and other conditions. And some will require some accelerators or what we call catalysts. These are substances that will speed up a chemical change. Now, what are the ideas that we have to remember when we talk about chemical reaction? Always remember that you are forming brand new substances, and it may be, yes, of course, it will be the same element, same number of atoms, but when it bonds to another type of element of an atom, then you would see that the properties will change. Different substances react in varied ways depending on the arrangement of its electrons, particularly the valence electrons, because they're the primary key players of chemical change. Third, chemical reactions are always represented by chemical equations. Chemical equations are representations of the reactants and the products and how many are participating in the chemical change. The chemical equations have to be balanced as well to show that the atoms are not created nor destroyed during a chemical change. Atoms will just rearrange, but whatever number you've started, that has to be the same number in the end of the process. That's what we call the law of conservation of matter. So chemical reactions are everywhere. When you go to the kitchen, when you cook, from your raw ingredients, you would form a brand new substance and that's ready for eating. Respiration, our metabolic process in all living things, it's a very concrete example of an energy releasing process that will make all living things life possible. We can also see that in the simple process of dyeing our hair, or in the auto fuel wherein you would see that this is a very concrete example why our cars would move, because it's a catalytic process, a combustion reaction inside the engines that will make it possible for our cars and our machines to move. This is another chemical reaction that I would want to show, a very short video of Alka-Seltzer and vinegar reaction. So when we watch this, take a look at what's going to happen when you drop or combine your Alka-Seltzer tablet with your vinegar. Let's see if this is going to work. Okay. So you would see, you're seeing right now that when the tablets were dropped into your vinegar, bubbles are formed. So you would notice that there is a quick reaction between the tablet and the vinegar. So primarily, you notice that there are bubbles that will be formed, and when you try to touch also the beaker, when you do this, there will be a change in temperature as well. So what happened during that change? You observe that there are bubbles, and if you happen to do it actually, you would really feel that there's also a change in temperature. So there are evidences that will help us recognize a chemical change. Some of these are color change. There's precipitate formation. When we talk about precipitate, we mean these are the solid substances that are formed when you mix two aqueous substances. Aqueous means these are liquid substances, but when you mix them with no addition of other elements, you would see that there are tiny solid substances that are formed, and these are what we call precipitates. Other manifestations are the gas formation which you saw in the video of the Alka-Seltzer and vinegar, and there's also change in odor. In cooking, you would notice that, and it can also be temperature change because there are some reactions that are exothermic, which is an energy releasing process, and you would feel that the container will get warmer. It can also be endothermic, in which you would feel that the container will become a little bit colder because endothermic is an energy absorbing process. It can also be the change in acidity, in which the pH level of your substances will change during a chemical change. So these are some of the evidences that would help you know, that would help us recognize that there is a chemical reaction that's taking place. So when we say chemical reactions, these are really different reactions. And when I make an analogy of this, it's always the analogy of the different emotions that's associated with the different context that we have. So we can be happy, excited, tender, scared, angry, or sad, depending on the circumstances we're in. But nevertheless, it's a reaction to the different situations, to the different stimuli. So that's the same with the atoms. Atoms react depending on what are the type of reaction they're undergoing. So there are really different types of reactions. There are 5 different types that we will discuss today. These are the combination or synthesis reaction, we have decomposition reaction, single replacement reaction, double replacement or double displacement. These are commonly found in neutralization reaction, precipitation, and redox reaction, and it can be combustion reaction. Let me just give you an overview about these types of chemical reactions. When we talk about combination reaction, we mean combination of substances. So take note, when we combine, we start with more than one substances, and when we combine them we get one brand new substance. So when we see a chemical reaction that begins with more than one substances and ends with just one product, then we are having a combination or a synthesis type of chemical reaction. Number two, when we talk about decomposition reaction, decomposition is the opposite of combination. Decomposition happens when you start with one reactant, one substance, and then you decompose them, you divide them into one or more substances. Single replacement or single displacement reaction is when you have one element and one compound, and then one element will replace another element in the compound given. Fourth is the double replacement reaction, in which, since it's double, you start with two compounds and then they switch places. The fifth one is a simple organic chemical reaction, which is combustion, in which you have a hydrocarbon that mixes up with your oxygen gas, forming your carbon dioxide or carbon monoxide, and water molecules. So let me pause for a while, and then I'm gonna explain in detail these 5 types of chemical reactions. Okay, so this is the preview of the general equation of the six types of chemical reactions that I just discussed. So combination is when you start with usually two or more substances, then they combine and you see one product because it's combination. So you combine all the reactants to form a single product. If it's decomposition, it's the opposite of combination. So you start with one substance and then it can be broken down into two or more products. When we talk about single displacement, you start with one element, you add it or it reacts to a compound, and if A is more reactive than either B or C, it's gonna replace it. So in this case, A replaces B because A is more reactive than B, so B gets displaced and A will bond with C. So single replacement, one element replaces another element in a compound. For double displacement, you start with two compounds, AB plus CD, and then they exchange places, so you get AD and then CBC or CD. This is sometimes CB because the metal has to be written first, then followed by your non-metal, which should be CB. And then combustion reaction, we have a hydrocarbon combining with oxygen gas, forming your usually carbon dioxide and water as your product. So generally, that's the overview, and These are the examples of some of the common chemical reactions